The objective of this lesson is to add to one whole as a strategy for adding two fractions. Students have already been taught the strategy of making 10. This knowledge should transfer to making one whole when working with fractions. During this lesson, students should focus on the sizes of each number and how much more is required to obtain one whole. Students have also worked with simple equivalent fractions in previous grade levels. This concept is another strategy to help students when adding fractions. Let's begin with our first problem. London is mixing paint to make her favorite shade of purple. She mixes 3/4 of a cup of red paint with 1/2 of a cup of blue paint. How much purple paint will she have after mixing the two colors? The equation that represents this problem is 3/4 plus 1/2 equals A, where A is the answer. One way to decompose the addends is by starting with the 3/4 and try to get one whole first. 4/4 make one whole. If the first addend has 3 of the 4/4, only one more fourth is needed to make the one whole. 1/2 is equal to 2/4. Take the 1/2 and rewrite it as 2/4 or 2 1/4. Take one of the fourths and put it with the 3/4 to make one whole. There is 1/4 left over from the 1/2, so there is one whole and 1/4. A equals 1 1/4 cup of purple paint. A second way to decompose the addends is to look at the addend 1/2 and see that only 1/2 more is needed to make a whole. The addend 3/4 is the same as 1/2 plus 1/4. So the equation can be rewritten to read 1/2 plus 1/4 plus 1/2 equals A. Combine the two halves to make a whole. Now the equation reads 2/2 or 1 whole plus 1/4 equals A. A equals 1 1/4 cup of purple paint. Let's examine one more problem. Jade and Jordan made some trail mix to take on a hike. They used 2/3 of a cup of dried cranberries and 5/6 of a cup of dried mango in their trail mix. How many cups of dried fruit did they include in their trail mix? The equation to represent this problem would be 2/3 plus 5/6 equals F. The F stands for the fruit. The first addend is 2/3. Let's model this using fraction circles. To model 2/3, divide the circle into thirds and shade in 2 of the pieces. The second addend is 5/6. Divide the second circle into 6 equal sections and shade in 5 of the pieces. One way to solve would be to make the 5/6 a whole. In order to do this, one more 6 must be added to the 5/6 to make the whole. To get the last 1/6, divide each third in half to make 6 and rewrite the 2/3 in terms of 6. 2/3 is equivalent to 4/6. Only one more 1/6 is needed with the 5/6 to make a whole. Decompose the 4/6 into 1/6 plus 3/6. The equation now reads 3/6 plus 1/6 plus 5/6 equals F. Add the 1/6 to the 5/6 for 6/6 or 1 whole. The equation now reads 3/6 plus 1 whole equals F. F equals 1 3/6 or F equals 1 1/2. Since 3/6 makes half a circle, Jade and Jordan had 1 1/2 cups of fruit in their trail mix. The objective for this lesson was to add to one whole as a strategy for adding two fractions. We met this objective by rewriting fractions addends to have common denominators and decomposing the addends to make a whole. We also represented the problems visually with fraction strips and fraction circles.